and we are really appreciate your interest to participate in this event to learn and to get trained on the robotic technology. And we also especially thank Mitsubishi company for them, as they have also agreed for the training and they have arranged it in a very short time for the benefit of students, faculty, and industries. And I would also like to thank our management and head of the department, Dr. S. Harvardagini Madam, for encouraging us to do this program. And uh, today, as we will have this training program for 2 days, so it will be today and tomorrow. So the timings, as you all know, from 10:30 to 12:30 p.m. So I would also like to inform you that all of you, all the students who are participating and faculty who are participating can get the maximum benefit out of this training, so that you will have something to take home after these sessions. And uh, to tell about our Mitsubishi or uh, ATC center, we have a specialized ATC center in the college, in our college, which is one of the 7 colleges around the country, and we have been in the last 5 Mitsubishi electric competitions, and all of them we have been one or the other uh, prizes, or we have received one or the other prize, and we are proud of it. And also we are having authorized training center, which is under which we are doing all these activities. And this year also we have few activities. If you are interested, you'll be getting the notifications after this. And for today's session, we will study, or we will have robotic basics. And to take us through this training, we have Paras Mehta, who is the senior engineer, FAC, Factory Automation Development, Mitsubishi Electric India Private Limited. And we are happy that he is the senior engineer and also in the FAC center, and he's taking care of the robotic training, repair, and maintenance also. So we are glad to have him with and we welcome you, sir, Paras Mehta, sir. And through this session, we'll be learning the basics. As you can see, we'll be learning few of the basics of the robot, device configuration, and few things. Along with that, we are going to travel through this training. So robotic operations and teaching programming with RT toolbox, and teaching pendant robot applications. So you'll be able to understand what the real-time environment will be and how you are going to work out with the robotic technology. So that's brief about what we are going to have in this 2 day session. And once again, I would kindly suggest and encourage all the students and participants to take maximum out of it. And if you have any doubts, you can just make a note of that, so that you can ask at the end of the session with when the questionnaire is asked by the trainer, and see that all of you are actively participating in the session. So before we give up the session to the hand over the session to Paras Mehta sir, uh, I would like all the participants to switch on your cameras so that we can have a virtual group photo. All the students and participants, kind request to switch on your cameras to have a group photo. Meanwhile, as soon as the group photo is finished, keep your notes and pen ready so that you can note few points. Please, all of you, mute yourself, please. All of you are looking good. You need not correct your hair and style it before the cameras. Yeah, few more are there to switch on. We'll wait for sir to tell whether the photo is taken or not. Thank you, sir. Thank you so much. So I would like to hand over the session to Paras Mehta, sir, to take over the session and take us through the training. We welcome you, sir, once again. Thank you so much for accepting our request and giving your valuable time and taking initiation to transfer your knowledge that you have gained through years with a lot of toil and struggling for all of our participants. Thank you very much, sir. Session is over to you, sir.
Hello, good morning, Pramod San. Actually,
Good
my
morning.
connection got break in between. I just joined.
Oh, sorry,
Yeah.
sir. It's okay. Fine, fine, sir.
So, good morning, everyone. Myself Paras Mehta from Mitsubishi Electric, and I am in FSC Gurgaon, taking care of robot training, repair, and maintenance. So, today we will be going to learn how robot works, how to make a program, and what are the features we are having in the software, and what are the different models that we can select as per our requirements. My screen is visible to all. Yeah. So we will start with the introduction of robot and what are the advantages and anatomy of robot. And then we will see the technology, what are the coordinates and applications we can use in a robot.
Sir, you can
It's
just,
a
sir,
better
excuse me, sir.
way.
Sir, you can
Yes.
put it on the slideshow, sir, so that the screen appears bigger. Yeah, yeah. Good, sir. Good, good. Thank you, sir.
Now it's visible.
Yes, sir. Yes, it is. Thank you, sir.
Okay. So we will see the control wiring for our emergency inputs and outputs and our booster, and we'll see how our teach box works. Then we'll see what are the type of softwares we are having in Mitsubishi Electric, and then will in software we will see how to create a new program, how to create a new project, and what are the features we can use through our software, how to teach, how to make a new program, and how to set the robot origin and home position settings that we will see in these 2 days. So today we will be covering most of the part of our software and teach box operation, and tomorrow we will be doing special program for two program we will make. One is pick and place, and second one will be the palette program that robot automatically will pick and place the object and place in the palette form. So what will you learn at the end? Industrial robot types, terminology, types of robot, wiring, RT toolbox software, reading, writing the backup in the controller, and the creation of the sample programs. So we'll start with the introduction. What is a industrial robot? It is a reprogrammable multifunctional manipulator. The robotic arm is called as a manipulator, and the controller will control the arm. So, and designed to move material parts, tools, or specialized devices through program motions for the performance of variety of tasks. Like most of the applications that robot use is a pick and place, that is repeatability is very good and all these things. That's why we use industrial robot, and it's very fast. So there are six type of industrial robots. First one is articulated. There are two types, vertical and horizontal. Vertical will be having 6 axes and horizontal will be having 4 axes. And second one is Cartesian, that it will provide only three linear motions that I'll show. Third one is cylindrical. These operate within a cylindrical shaped work envelope. And fourth one is delta. These spider-like robots are built from jointed parallelogram connected to a common base. So these are the type of robots, like vertical articulated, horizontal, Cartesian, cylindrical, and delta. So what are the advantages of industrial robot? That it provide repetitive work cycles, hazardous work environment, it can work easily, and consistency and accuracy is very high. And difficult, that are the tasks which are very difficult for humans, the robot can perform. And multi-shift operations, it can work for a full day and continuously. And programmable and flexible, we can change the program as per our requirement. And it's flexible, we can pick and place the robot to our as per requirements. And this interface to other computer systems, we can connect other modules also with the robot for controlling. So this is a 6 axis vertical articulated robot. So it consists of joints and links. Joint provides relative motion and links are rigid members between joints. So we can see this is the base of the robot, and this is the J1 axis, joint 1. This is joint 2. This is joint 3, and this is joint 4. And this is joint 5 and 6. So it is a hand-like structure, and each joint provide a degree of freedom. So there are 6 different degree of freedoms in 6 joints. 3 degree of freedom are 6. That means that it can move in any direction like X, Y, Z. 3 linear motion, and 3 will be our angular motion. That will be ABC. So robot consists of 2 sections, body and arm for positioning of objects. Second one is wrist assembly. So this is the wrist assembly, and this is body and arm. This is body, arm, and this is wrist. So with the help of all 6 joints, it can move to any place within its workspace. Applications would be material handling, painting, welding. That we will see a few of our videos. So robot anatomy is it is made up of 6 axes. Like it is having 6 motors for each rotation of axis. So we can see the vertical robot workspace. Workspace means the how far robot can move in its workspace. So each and every point in the workspace will be accessible by the robot. And now we'll see description of various envelopes. Envelope means how the that the area where the robot can move its arm maximum from its base. So this is the maximum envelope. We can see robot can move in this envelope at any position. This is the restricted envelope. Restricted means uh, the space where we provide the restriction like fencing and any other module or any other motor we have mounted for the safety, and any door we have mounted. So this is the restricted envelope, and operating envelope will be the black part, that is where the robot will perform its operation, or the application we have defined will work in this operating envelope. Same way, the side view we can see. So again, the maximum envelope that encompasses the maximum design movement of all robot parts, including the end effector, workpiece, and attachments. So restricted is this is that portion of the maximum envelope which a robot is restricted by limiting devices like fencing. And third one is operating this is used by the robot while performing its program motions. So this is our four axis robot. This is called as a SCARA robot. SCARA means selective compliant articulated robotic arm. This means that the robot provides substantial rigidity for the robot in the vertical direction but compliance in the horizontal plane. This makes ideal for many assembly tasks. So this is the special type with mostly it is used for material handling for picking and placing and assembly, loading and unloading. So again, this is the workspace for 4-axis or SCARA robot. In this complete workspace, it can move to any point. So we will see the four joints here. One is J1 axis that can move to minus and plus direction. This is J2. This can move in both direction, minus and plus. Actually, each axis has a motion limit that is defined so that it will not rotate in a complete circle. But as per our requirement, we can edit our motion limit of each axis that we will see in our RT Toolbox 3 software.
Yes, in the chat box, just participant raised a question. What does the envelope means?
Okay, okay, I'll just check.
Dear participants, with attendance sheet has been shared in chat box. Please fill the attendance form. So
Yeah,
please,
this link.
yes, yes. Please, sir, here it mentioned.
Okay, I'll just explain again. So envelope is the maximum is this the maximum design movement. Like in this picture, we can see the actual factory default setting came with each axis limit. So if I move the J1 axis, so it will move to this end to this end. So this is the maximum envelope. It will not go behind this point. So this is the blank area behind. It will not go at this side. So envelope means the area that the robot can move to its design parts. Like I can show you in right now for more better understanding. As an example, I will show this in the software. So this is my FR series 7 kg robot. So for envelope, maximum envelope, we can like this. The J1 axis is moving from minus 240 to plus 240. So this is the limit as a factory default we have that comes with the robot. So if I move the robot parts completely. So this is the maximum reach of the robot, and I'll make a circle like this. So right now it's 240 in positive direction till going to minus 240. So this is the complete workspace. But now what is happening? We need to check the envelope. So we will set our limit as per our requirement, so that in this for this we can set this as our limit, and we can set this as our limit. So this is the maximum envelope we are defining for the robot. Like we have just moved minus 240 to plus 240. So this is minus 240. This is clear to all. And we can also restrict the envelope. That will I'll also show you in that software moving further. And we can also define this operating envelope also. So I need this. So this is 70, and this is minus 70. So I need this envelope as a maximum envelope. So what I will do, I'll set the limit motion limit and write it to the controller. Yeah. Now we will see the maximum envelope that we have defined is this much and this much. That robot will not, should not move behind this point and this point. So this is our maximum envelope. So it will not move behind this. So this is clear. Please raise your hand if it's clear. Thank you. So we're moving further. Now we will see the J3 and J4 axis motion, that this is moving in upward direction and downward direction is the J3 axis, and rotational will be the J4 axis. For better understanding, I'll just show one video. So this is the Scala robot. This is moving in J1 direction. This is J2. This is J3 and J4. Likewise, we can move to its workspace, like it's moving like in rotational. So this is the SCARA robot. So now we will see the robot terminology. One second, I'll just share my window. Just hold on a second. Okay, now the robot terminology. So there are six types of terminology, like what is the reach, what is the maximum speed, what we call that payload, and accuracy, repeatability, and resolution. So we'll first discuss about reach. The reach that I have shown, like the maximum distance the robot can cover is the maximum reach, horizontal distance from the robot base. So this is the base of the robot. From here to maximum distance it can move is the robot reach. And maximum speed, the robot moving at full extension with all joints moving simultaneously in complementary directions at full speed. The maximum speed is the theoretical value which doesn't consider under loading condition. And the third one is payload. It is the maximum load or maximum weight carried by the robot manipulator at reduced speed while maintaining rated precision. So this is like we can mount our tool or hand at this robot arm in SCARA, and here at joint 6, here we can mount our tool, like I have shown in a video, that is used for picking or placing. So that is the weight of the tool that we are mounting on the J6 axis of vertical and J4 axis of SCARA robot.
No problem. Once you fill the measurement, that will be the
So these ratings are highly dependent on the size and shape of the payload due to variation in inertia. So we need to select the size and shape accordingly, so that robot cannot like robot is taking proper load
Are you in online?
as per the designated model. So this is accuracy. Accuracy refers to a robot's ability to position its wrist end at a desired target point within the work volume. So this is the accuracy.
I'll share you the link.
And repeatability, I have the ability of a robot to return repeatedly to a given position. Like uh, we can see the robot is performing the same cycle so this ability of the robotic system and mechanism to repeat the same motion or achieve the same position and motion. So it will move to a cycle and it will end at its home position. So resolution is the smallest increment of motion or distance that can be detected or controlled by the robotic control system. It is a function of encoder pulse per revolution and drive. Example, reduction gears ratio. So resolution is we can is
మీరేనా?
move to 0.01 degree. So this is the least count we can say. And at high inching speed, there are two options in our teach box that we can select with our speed up and down. And from here, so this is the low inching, 2 is high inching, and this is the speed we can select from 5 to 100. So resolution means the smallest increment of motion distance that can be
Again,
detected.
share the
So
screen.
this can also we can also change the L inching degrees after pressing, like I can change it to zero point 0.1, that it will move zero point 0.1. As per our programming specification, we can also change the speed. In jogging speed, we can change the speed of this is the least count moving resolution. Now, degree of freedom. Each joint axis on the robot introduce degree of freedom. An industrial robot typically have 4 in SCARA, for example, 6 in articulated systems.
జాయిన్ అయ్యారా? అయితే
3
రిజిస్టర్
degree of
చేసుకోలేదు.
freedom allow in space like XYZ, while other
నెట్వర్క్ ప్రాబ్లమ్స్
two
ఆదా నాది.
for indication of
మీకు ఎలా వస్తుంది నెట్వర్క్? బ్రేక్ అవుతుందా? అక్కడ కూడా బ్రేక్
so
అవుతుందా?
we can see this degree of freedom in a well you
హలో సార్,
degree
ఎక్స్క్యూజ్ మీ
of
సార్.
freedom to allow.
పరస్ మెహర్ సార్, ఐ థింక్ వాయిస్ ఈస్ బ్రేకింగ్ సార్. ఐ థింక్ పూర్ నెట్వర్క్ కనెక్షన్ యువర్ సైడ్. Dear, dear participants, please fill that attendance form which has been shared in chat box.
Z. So if we move
Yes, sir. Can you
in,
share PPT?
yeah, I'll share you after the
No,
session.
sir. No, now here it's not visible, sir.
Now it's visible.
No, 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 sir. No. Can you please present now, sir?
No.
Yes, yes.
Okay. Screen is visible.
No, no, sir.
Hello.
Sir, screen not
Screen
visible.
is not.
Not visible, sir.
Okay. Just. Okay, I'll join once again. There
Okay, okay,
must
sir.
be some. Hello.
Yes, sir. Now it is
Okay, okay. Thank you so much. So this is have you seen this PPT?
yes, sir. Yes.
Yes. So we are discussing about the degree of freedom. Three for six axis, three will be XYZ, and three will be your pitch and roll that we can see in our RT toolbox here. So we can see the coordinates x, y, and z. So that is the plus x, y is the plus y, yellow one, and blue is plus z. So if we move the robot as per the coordinates, we can move the robot in plus
మీటింగ్కి ఫస్ట్ అవర్ వెళ్ళాను సెకండ్ అవర్
plus y minus y plus z minus z.
సార్ ఇక్కడ ఉంటారేమో చూడండి మరి
So there are three linear motion. One is the degree of freedom is this, and ABC is this roll. B is providing this motion, and C is C we can see from here. This is roll. So this is clear. 6 degree of freedom we can reach at any point. So robot coordinates. There are four type of coordinates, like joint coordinates, word, tool, and user. So what is the coordinate system? Coordinate system defines a plane or space by axis
అటెండెన్స్
from a fixed point called the origin.
మెసేజ్ పెట్టారు మీకు
So where is the origin that we will see in each coordinate? Basically, for word coordinate, the origin is at the base of the robot. Robot targets and positions are located by measurements along the axis of the coordinate system. So, what is this means that in joint coordinate, first we will see the joint, then we will see the word. So in joint coordinate, each axis we can move J1, J2, J3, J4, J5, J6. So there are no Cartesian coordinates like X, Y, Z, ABC that we will use in word. So in joint coordinate, we can move the robot each axis. I'll select the joint. So this is plus minus J1, this is J2, this is J3, this is J4, this is J5, this is J6, the last wrist rotation. This is J6. Only the wrist part is rotating. So next is word coordinate. So This is saying that the space by axis from a fixed point called the origin. So for word coordinate, the origin is at the base of the robot. So we can say the XYZ value will be 000 here at the base, and wherever the robot point will take for even picking or placing the parts or the workpiece, it will take all the to an value of 0. We can see so it is now base with respect to this. The screen is visible. So for tool coordinate, the values of XYZ will be from this wrist side because the tool is mounted on the wrist. So this value will be 000 at the wrist point. For user coordinate, the coordinate XYZ will be 0 at the base, the edge of the workpiece. It will take all the motions from this 000 point. So we need to define this point user coordinate in the software. Now we will see the different type of models in FR series. This is our latest series of robot, like vertical and horizontal. There are two types. These are the Scera, and the last one is our ceiling mounted. So as per our application, we can select our robot, the the amount of load we are mounting on the wrist of robot, that we can select the kg at which is what is the load, what is the weight of the tool. According to that we can select our model, like this is 4 kg, this is 3 kg, this is 7 kg maximum load it can bear, and this is 13 kg and 20 kg. And as per the kg, the weight of the robot increases, also the reach of the robot increases, because like it is providing 7 FR, 7 FR L. L means the long arm, it provides the more reach, and this is a special type 7 FR LL. This is the longest arm robot, having the maximum 1500 reach. So what is the nomenclature that we use for defining a robot model? So this is RV. RV means the vertical robot we are selecting, and indicates this box indicates the kg. If it is written 4, then it will be 4 kg. 13, 20, it will be 20 kg or 13 kg. So FR is our series, and J is the like if J will be present, then it is vertical 5 axis robot, and if it's not there, then it is 6 axis. If it's there, then it's 5 axis, 5 axis type. So it will be defined as RV4FRJL. L means the Long arm, if L will be present in the model number, then it is a long arm, or it is, if it's not available, then it's a standard type. So indicates the environmental specification, like it is like if it's there, then it's general specification, and if M and C is there, then M donates the oil mist specification, like it can work in oil, and C is clean base, but like dust free specification. And this dark circle indicates the standalone, like if D is present here, then it's standalone. If R is present here, then it is IQR compatible type robot. And SXX defines the special module and the internal wiring that what we are using at our workspace. Like we have used a sync type wiring or source type wiring. According to that, we can select. Same way, this is the FR series horizontal type robot. We can like same select the our payload and reach, and this is the Z stock, the up and down motion of J3 axis, how far it can move. Like for 20 FRH and 12 FRH, it is providing Z stroke 350 mm and 450 mm. So according to that, we can select the robot model arm. And this is the last special type, FR-HR. This is the ceiling mounted, mounted on the wall of seal. It is the smallest type, 3 kg, and having a reach of 350, mostly used for pick and place application, like for mobile phone or any other small product, we can use this robot. So this is the same nomenclature for horizontal type. The difference is same. Series
Sir, your voice is breaking, sir. Yes, sir. Paras, sir, I think some network issue. Your voice is not audible, sir. Not clear. I think your side have some network issue, sir. Your voice is breaking.
now it's clear.
Now it's clear, sir. Yes, it's clear.
Okay, thank you, thank you. This part is clear to all. The model nomenclature. Okay. So there are three types of controller. This is the D type, Q type, and R type. D type is the standalone type. We can use for hard wiring, or with the help of CC-Link, we can perform our operations or applications. This is the Q type and R type. This is used for the long line for some application, that we can connect this one CPU with multiple controller. So this is used for controlling all the 4 or 5 robots working in the same line with the help of one Q type CPU. So this is add-on CPU connected with the controller. Same way, this is the R type connected with the controller. So specially this is used for a line which is having 7 or 8 robots and working for like in rhythm, and D type is the standalone time. This is the only, like we are having one cell and one robot. We can use this D type standalone type controller. So there are two type of TB. This is the advanced level R56 TB, and this is the basic level R32 TB. That both TB we will see what they can do in the future. So in this video, the robot is self-tracking the all the parts which are coming on the conveyor. So it's like segregating both the parts with the help of vision camera. So in this, the camera is integrated with the robot. When the camera see any device of there are two colors, so it will automatically pick that part. So this is the application line tracking. Or another one is the machine tending. So robot is just performing an operation of picking the workpiece from the conveyor and putting it into the machine, and picking up the finished good and placing it to final position. So here we can see the synchronization of robot with these two machines. Machine is finishing the job and second one is doing the job. So this will utilizing the whole time for making the part, and this is working on both sides with this synchronization. Now the third one is the screw tightening. This is our Scala F series robot. So center there is a screw feeder, and robot is picking and screwing the workpiece. So this is the screw assembly application. Now we will see the power and control wiring for our latest robot FR series CR800D controller. Here we will see the what are the connectors and options available for wiring, and what are the these two slots and what are they used for. So this is the front view and this is the rear view. We'll start with the rear point. So this is the AC power supply. So there are two type of power supply we can uh, provide to the controller. This single phase or three phase, which will be written on the this sticker. We can see this is 200 voltage class. So this is a single phase AC in, and second point is used for earthing, and there are at the back side there is one air exhaust, and on 3 CN1 this is the connector for connecting the robotic arm with the controller. And for now this is for no use, it's just a connector. And this is CNUSR 11 and 12. These two connectors are used for our switch selection. So we need to do wiring on these two connectors. Mostly the CNUS R11 connector is used, that we'll see in the wiring diagram. And on the front side, there is a air intake fan. Two fans are mounted inside this cover, which are taking the air inside. And one filter is also there for cooling down the PCBs. And sixth one is the teach box connector. Hard wiring purpose, IO optional card like this. We can see here. This is slot 1 and slot 2. And 17th is the SD card. Taking, and this is the USB and PC. These are you like if we perform want to perform any program, mini USB LAN, additional access with the software you
Sir, again, network issue, sir, I think from your side.
can connect this option.
Sir, audio is not clear, sir. I think network issue again.
Now it's clear, sir. Hello.
Ah, sir. Yes, sir.
Now it's clear.
Now it is clear, sir. Earlier, it has problem.
Okay, thank you. Screen is visible to all.
Yes, sir. It is visible.
So option one and option this is the like configuration configuration.
Hello, sir. Again, network issue, sir. Your voice is not clear. Dear participants, please be online with Sari joining. Please regret for inconvenience cost. Regret for inconvenience cost. Sir, disconnected, sir, yours. Okay, okay, sir. Fine, fine, sir. Okay.
My voice is clear now, sir.
Yes, sir. Yes, yes, yes.
Sorry for the inconvenience. Actually, the network, I think, some issue. Okay, now we are saying this eighth point is for hand fuse. This is the extra safety provided to the controller for like if there is any shorting in the main motherboard, then it will protect the motherboard, the main CPU. And seventh one is the LED panel. It will show the four LEDs. This power, auto, error, and ready. We can see at this point these four LEDs: power, auto, ready, and error. If there will be any error, it will show the red light, and for power, it will show.
Yes, sir. Yes, sir. Sir, which is
So this is the connection between our controller and robotic arm. This is the cable. We called it as machine cable for connecting the robot and controller. And this is the AC power supply we are providing to this connector. So this is CNUSR11 connector. The numbering is provided like 1 to 16 on the upper lane and 17 to 32 on the bottom lane. Now we will see these points 1, 2, 3, 4, 5. What is the need of these points and where we need to do the wiring for and for providing any input to the controller and taking out any output from the controller. So here we can see the 14th and 30 number point in that connector. We can give the input for emergency stop, external emergency stop. Actually, there are two point for each input. If it's not working, we can also connect on 7 and 23. 7 number pin and 23 number pin of CNUSR 11 connector. Same way, we can connect the door switch input 13 and 29 and 6 and 22. So there are options for these two. Either we need to connect on this or either we need to connect on this. So next one is the mode selector. This is the auto or manual connection point pins for giving input for any manual mode or auto mode. So these three are necessary for booting up and running the robot without any error. So these are the again three types for getting the output from the controller, like mode output, like controller is in manual mode, so it will give the output signal that it's in manual mode. Again, 4 and 20 is same as 11 and 27. Again, 10 and 26 for emergency stop output. So it's giving output to another PLC or some connection we have given or through hardwiring that emergency stop output is taken, or like 8 and 24 and 1 and 17 is also the Same for robot error output, that it will give the robot is in error. So this is the optional card that we use to mount in our controller for controlling the robot with the help of hard wiring. So there are two types, 2D7Z368 and second one is 2DTZ378. 68 is sync type and 78 is source type. So for sync type, common is 24 volt and the input we are providing is sync type 0 volt. And for source type is this. So source type is we are giving the input as 24 volt and it is connected with 0 volt. So this is our 32 TB and 33 TB. And what is the 32 and 33 difference? It is the only difference between these two are connector connecting the controller. Rest of the teach pendant is like same. So we will see what are the options available in this teach pendant. We'll start with first, this is the emergency button, the red one, and the fifth is the LED panel, like it's power on, it is auto enable, or it is having servo on or off, or it is in error. So LED will blink or high when it's power on or getting any alarm or it's getting servo on. So these two buttons, this is the second one is so this button is for enabling and disabling the TB, and this is for enabling the servo on. So every time when we using the robot and we want to jog the robot, we need to press this to left side or right side, both side it will work, and we need to press this uh, servo button for getting servo on. After pressing this button, we need to press the servo on button for activating the each axis. Now the fifth one is the menu selection key that we will see in our display, and this function key is the selecting the functions, and this monitor key is we can see the monitor like input output with the in this panel, display panel. This jog button is required when we used to move the robot, like we have turned the servo on, and after pressing the jog we can jog the robot with these 6 plus 6 12 buttons like X, Y, Z, A, B, C. And again, if we are moving in joint mode, then J1, J2, J3, J4, J5, J6. So we can move with these all buttons. So, and these two buttons are for speed increase and decrease in jog or auto mode. And these four buttons are used for selecting the option that we need to select. And this is the stop button. When robot is performing in auto mode, we can just press the stop button and start again with the cycle start button. Clear is the, if we are performing or writing any program name and we want to clear the name again, then we can press clear. Execution is the execution button is for used for if we are entering any parameter or entering any program name or doing any settings on in the program, then it is like executing the same setting. And again, this whole button 1, 2, 3, 4, 5, 6 till 0, and this is the numbering. This is used for naming the program or any writing the parameter. This whole complete. And this hand is used for operating the hand, which is connected to the wrist of the robot. And this character button used for uh, using the alphabetical or numbers. We can switch the settings with pressing the character. And this is the reset button. If we get any error, we can press the reset button to eliminate the error. So this is the complete teaching box options. This is the detail that I have explained. This is the special type TB. This is having the RT Toolbox 3 software inbuilt, and we can just perform each and every making the program or writing any parameter or doing any settings. So we don't need any laptop for connecting to the controller. We can do everything in this TV. Same, this is R56 and R57 TV. The only difference is the connector is different, and all that teach pendant is same. Actually, 56 is used for CR our FR series, and 57 is used for our previous series, that is F series. So both connect controllers are different, and both TVs also are different with connectors. Only the display is same. So in this also, this is the enable switch, this is the selector switch, third one is the emergency switch, fourth one is the stylus for use for this touchpad, fifth one is the indicator, and this is again 14th is the hand, and 15th is the jog button that when we turn on our servo. This is 24th is the servo switch that we have seen here. This servo switch is in this direction, and 23rd is the holder, and 16 is the buttons used for jogging the robot in plus and minus direction, and this is the execution button again, and this is OK and selection and cancelling button. This is, and this is cursor button used for selection, and this is the reset button. Menu button and return button. This is the back button, and this is the menu button, and this is the complete up and down button for speed up down, and this is the home position button, and this is the 11th and 10th. 11th is the servo key that we need to press while servo on. Reset and servo. Yeah, 9th one is the servo key, and 10th one is the reset key. And this is the error we are getting. So this is for getting the error message, and this is the stop button. So these are all the buttons. We can perform any operation with the help of this all buttons. So Software types, there are two type of software, RT Toolbox 2 and 3. In 3 there are three versions, like RT Toolbox 3 Mini, RT Toolbox 3 and RT Toolbox 3 Pro. So in Mini we can do basic operations, basic version. It will be connecting with the controller and we can do programming, debugging and monitoring only. But in Toolbox 3 we can simulate also, like we can do simulation, we can check our what is the cycle time we are getting after performing any required application, and we can also perform the layout examination. In Pro we can use the integration with SolidWorks, like we can draw some shape in SolidWorks and we can insert this file, CAD file or SolidWorks file to the controller. So this is the Pro version, and from this file the robot can will pick up that shape and can do perform on that shape with the help of these two softwares. So this is our RT Toolbox 3 software. You will see like this window when we start. When we open this RT Toolbox 3, so first of all this window will appear. After this window, we need to assign one workspace, create one workspace with the name that we can enter anything here, like new. We press new. We can enter the workspace name. Then we will select the model of our robot that we need to do for if we are taking or connected with the controller, we can go online, or another option is we can just simulate the robot. So we will enter the details, project name, it's taking RC1 by default, but we can change the name. And second one is the series type, maximum load, and what is the model of the robot we can select in this tab. So after this we need to do the settings for the communication with the controller, that we need to connect with the USB or Ethernet cable that we will select in this method. If we are using the IP address Ethernet cable, then we need to check the IP what is in the robot, and we'll set the same settings to our laptop. So this is the program language. Malfa Basics 6 is the latest language. By default we will use this. So this is the travel axis. Like if we are using any additional axis, then we will select this, or else we will not use this. So these four are the mandatory. This is the 1, 2, 3 and 4. So these four are mandatory. We'll just can finish it up here also, because if we are not using any tool or any robot additional axis, or we don't need to go after that this window. So this is the same additional axis. We are selecting any tool. We need to define the dimensions, and we need to define the size and weight. So after finishing, pressing the finish button, we will see this tab that do you change the operation mode. It's asking that do you change the operation mode, because for this going online we need our robot to be in auto mode only. Like if the robot is in auto mode and this switch should be in off condition. If will be on, then you will see the light appearing. But if this is must be in off position and our mode will be in auto mode, then we will go online if we are connected with the controller. And if just we are just simulating, then we can select the simulation. So after simulation, we will see this window. So this is the 3D monitor of our robot that we have selected here. We have selected the robot model number here. So we will see that same model in 3D monitor. And this is the teach box inside the RT Toolbox 3. So for new program, what we will do, we will just press on this simulation. So we press the simulation. In this, we check these options are available. Then we right click on program. Right click on program. Then we will select the new. So after selecting the new, a new window will appear like this. Then we will enter the robot program name, the what we need to define. Like it's taking new one. We can take any name, test, online training, something like that. That we will see. Now it's the after this OK, we will see this new program window. In this, we can write the program here. Here we will write the program what we want the robot to do. So according to our need, we can make the program. And we can take if we are taking P1 P2 point, then we can add the point here by pressing the add button. And in P1 and P2, we need to define the position that we are saving in our actual robot. So this is the new program method. Now how we will take the backup and restore the backup in the controller, that we can see this backup line here. Backup. In this backup, we will see this all program parameter system program. And in this program, we can see this folder. So for taking the backup, we need to right click on all. After right click, we will see a backup tab. Then we can see this window, this backup window. And now I'm taking all files, or I'm taking only the programs, I'm taking only the parameter files, or I just need the system files that we can select from here. And parameter list files also we can select. And while browsing, we can select the path, or else it will take the backup folder itself that we have created the workspace initially. In that backup, it will automatically take the backup path. After OK, it will take the, like it's showing the RC1 is the project name we have assigned, and in others it will taking the backup program. Again, for restoring, what we will do in backup, we'll just right click on this folder we have created. We can restore from here, and this window will get appear. In this, we can select the program, all the parameter files that we need to restore. And what are the changes we required in the robot? if we want to change the origin, then we will select this. If we are putting that backup to some another robot, so we will need to change the robot arm series serial number, then restore the file, restore operating information. What we need, we can just select the option and press OK. So it will be taking the same path for getting the backup again. Like we have created this backup, it will just pick this file and restore again. So in last, this is the error troubleshooting. In error troubleshooting, whenever the error occurs, the error LED will blink or turn on. And this is the table that describes the complete what is happening, what is the cause, what is the like error message, what are the measures we can do to eliminate this error. And we can take the error history also, that I will show you in RT Toolbox 3 software. So this is the complete robot basics that we will going to learn in our software.
Participants, do you have any queries? You can unmute and
Yeah.
speak, or you can post in chat box. It is the time to clarify your doubts.
So any issue in like we will just do all this, perform all this like origin setting, home position we will do, and this backup and restoration we will do. If you have any doubt, can ask me. Or after the actual operation with this RT Toolbox 3, you can ask some queries.
It is again remind to all participants, attendance form has been shared again in chat box. Who haven't filled the form, please go through and fill the attendance sheet.
Now we will see all these things in our software. So this will be the very interesting part in this software. So we will be creating a new workspace. Okay, I'll take one workspace like CVR or I'll take training. I'll take a workspace.
Sir, in chat box they raised a question here.
Okay, I'll check.
Does the RC control the robot?
Yes, the complete controlling provides by the robot controller, and this is the only arm. It is just a structure having a six servo motors, just a servo motors that is taking command with the help of RC. That's why we call it as a manipulator. Any other doubt? Yes, we can connect with our machine, other machines also, and we can perform each and every operation according to that. Actually, the tool, it depends on the tool what we are mounting. So when do we use RC? RC is like we have connected the RC with the robot arm. it will be always used. It will always be used because it will power on the robot, it will control the robot, it will jog the robot. Without connecting with the RC, robot will not can't do anything.
Is it clear, sir? Ramesh sir? Okay, sir. Sir,
Okay,
thank
thank
you.
you. So we will be moving to the software part. Here we will see the new workspace we have created just now, training college. We can see the name here, training college. Like after that, we need to select these first four options. Project name, I'll take, I'll enter RV4FRL, my robot model number 4FRL, and next. Here we will select the robot arm. So I will be selecting 4FRL. So I need to find the options for getting that model. So this is the CR800 FR series, latest series. There are three types. I have already told you the DRQ. I am using the D type for FRL, and I'll be taking the vertical robot because it's RV for FRL, so I will take RV. If it's FH series horizontal type, I can also select the horizontal. This is like we can see the horizontal type. We can also select anything. Like I have selected the vertical type, 6 axis, and load is my load is 4 kg, so I'll selecting the 4 kg here. So what are the options available for 4 kg are visible here. So my robot is 4FRLD, so I will be selecting this. And what is the difference between 4FR and FRL? It's the same L is present here, so it will be a long arm. We can see the difference in picture also. If I select this 4FR, then it is short type, and if I select 4FRL, it's the long type. So we can see the difference also here. So next, what is the our mode of communication? I will be using Ethernet. I will be using USB, or I will be using GOT. We can select here. So I will be using the USB. And if we connect with the Ethernet, that this IP address setting, this setting, we need to put in our laptop. Same IP we need to set. So I'll be taking for simulation we can select anything. I'll select TCP IP. Next. So by default the language is Malfa Basic 6. So I will be selecting this only, and in last finish. Just a second, sir. So we have received this window. It is asking, have you changed the operation mode? If I was connected with the controller, then I'll click on online and turn the mode switch to auto and turn off the switch from teach box. So I will be selecting the simulation now. So here is one another window we can say, see here. So simulation connecting is in process. Now, yes, now it's connected. So we can see, or otherwise it will be simulation. It's now showing the robot is in simulation. So this is our teach box for software. Again, this is a servo on button, off button, start button, stop button, and reset. And I will show all the options available here. Now this is our robot. We can select the movement type what we want. Like we are moving in linear motion, we can select this XYZ. We can select if we are moving in tool mode, then again 3 XYZ method we can select. So first I will take the joint mode, and this is the home position. This is the home position by default in every each and every robot. So first I will change this home position, and we'll see other options also. So in simulation, we have, if this operation panel gets cancelled, we can select this panel from here also, and from online here also. So there are these options. This is the 3D monitor. This is operation panel. This is program. We can see what we have programmed here. Select the name. This is a spline function. Spline function is like the we are editing any file, in inserting any file in the software, and we will see that pattern here. We can edit like this. In monitor we can see the signal, what is the signal robot is getting. And in maintenance we can check the origin data. What is the origin data? We need to initialize any battery or parameter, then we can select this, initialize. Maintenance forecast shows the life of the robot, like robot timing belts and grease life we can check here. So the standard life is 24,000 hours, and this much is remaining. For belt life also 24,000 hours is the total robot belt life, and this much is remaining. So this is the simulation. We can see it like it's a new robot. But what if we want to reset any grease or belt life? If we have refilled the grease, or if we have changed the belt, we can select the axis, but where we have changed the or refilled the grease, like this we can select and reset the battery life. So this is the forecast we can see, and for this we can take the backup also, like controller to PC. If we take the backup, like we are taking the backup for the reference that what we have done before, what was the life, and after resetting what is the life, we can take the backup both. So I have taken the training college as a workspace, and this as a project name, and in this others it is saving the maintenance forecast file. So I will save. So backup is complete for maintenance forecast. Likewise, we can restore that backup again. We can select this, open, and it will get restored in the software. So this is the maintenance forecast. Now we will see the origin data. For this user origin method, this will show the method that the user has selected for using the origin, setting the origin. So now it's not set, but the state is set because we have some values in data input. So these are the J1, J2, J3, J4, J5, J6 values. Because of this, we can because of this data, the origin is set right now. But I want my robot to be set origin by tool method or origin method that we can also select. So I will be using ABS method and will check the position. So in robot there is in actual robot there will be marking available on each axis. In simulation part we can't see that marking, but in actual robot we can see the marking here at J1, here at J2, here at J3, and here at J4. So we need to match that arrow for ABS method for at each axis. Then we can select the origin. So origin is why it is necessary. Why we require the origin? If we don't set the origin in the robot now, then it will not take any position from the reference 000 because we need to first define the origin for each axis so that it can take the value and show that value actual position value here. And if origin is not set, it will also not work in any Cartesian coordinate. It will just rotate in jog mode. It will only work in joint mode. Any other mode it will not work. So origin data I will be selecting ABS method. What we do after matching the arrows on each joint, each axis, we will select the all axis and set the origin. So now the status has changed to ABS. Now we can see the user origin method. What we have used is ABS method. So for each axis at this position, robot has been origined here. So now origin is done. We can use these three methods. We can enter the data. This data comes with the robot. Now we can see the data has been changed already because before it was some another like J1, J2 was 0 and J3, J4 was having some values. Now J4 and J6 is showing the 00 value. So after changing the origin, this data is also changed. Again, we can take the backup and restore the this data to our controller. Another three mechanical ways are there. Mechanical stopper. At each axis, there will be a stopper like this. We can see here, like J1, we can see this stopper. So we need to rest the J1, J2 axis here. Again for J3. This is the stopper for J3. This part will come and rest on this. So likewise, we can set this different method of mechanical stopper. We can only set the J1, J2, and J3 axis with mechanical stopper, and rest we mostly use these two method, tool method and ABS method. For tool method, we need to insert a tool at each axis. Actually, it's not visible in simulation. Yeah, we can see at J3 axis. Here we see one hole. This one J3. I will just check. Yeah, right. So we can see this hole here and one hole here. After matching this hole, yes, after matching this hole, we will insert one tool here that will cross through this body part to this long arm. So it is, if it's qualifying the both holes, then it is set for J3 axis. Likewise, we have at each axis we have these two qualifying holes. With this method, tool method, we can select. But if we don't have tool with us, we don't have data with us, this is the ABS is the easiest way that two arrows will be visible on the robot. We need to just jog the each axis and match the arrow on complete robot, and we will select the ABS method here, and set the origin and set origin. So this is the best and basic method. And now we can take the backup also for origin parameter. Uh, like it will show the complete values that is stored. Now I will select the save to file. Again, it is saving the file in others. In my project name, I'll write origin backup and save. Now, if I need to restore that origin again, then I will select the file from writing to robot and select this backup file and open. Then this is telling the transmit. Yes. After this restoring the origin, the controller will automatically restart. So we will restart the controller, and now it is displaying one error. Now the controller has been restarted. Now the origin is restored. So origin part is clear to everyone. How to set the origin, how to use the ABS method, how we can see the data of each axis.
Yes, sir, it's clear, sir.
Okay, and maintenance forecast method is also clear, na?
Yes.
Okay, we'll move further. So in for using the various parameters For programming part, we will do programming on day two. That is tomorrow. We will do the sample programming, and for this parameters also there are.
Sir, with the participants are asking that installation procedure for this software, just
Okay.
to do practice.
Okay.
Shall we have discussion on tomorrow, sir, about that installation process at the starting of section?
Yeah, we can just download the RT Toolbox 3 from our website.
It is
Everyone
available
can.
software.
Yes, yes. Yes, software is available on website. Everyone can download the latest version. And for manual help also, they can click on help and then manual and then RT Toolbox 3. If they require any operations, what are the features? If they are having any doubt, they can read out here. Any commands they need to check how to do the programming and everything. They can see in this manual RT Toolbox 3. Just show the contents. So this is the RT Toolbox 3 user changing the display language, how to download, starting everything. We can how to create a workspace, project, outline, this communication, whatever they want to know, they can have this. Any communication gap they are having, problem they are facing, they can check in this section. Any writing program, reading program, how to make command, everything is available in this manual. And also the troubleshooting, if any problem is occurring in controller, we can check through our this troubleshooting manual. Like any error it's coming, like I'll just like I have taken this motor overcurrent alarm is coming, so it will show H093 and will donate the number of axes. Like if it's 0936, then it is having problem in sixth axis, and if it's a 931 or 9323, likewise we can judge the axis where it is creating the issue. Likewise we can just check here, and any error we are getting 07 060 encoder no signal. We can check and cause and measures in this manual. Other manuals are also available here. Detailed explanation of operation is in this. We can see the programming part and wiring part also available in this. In troubleshooting is like this is the F series and this is FR series. So select the correct manual. We can also download from here. So for parameter, there are movement parameters, program parameters, signal, communication, field network, or safety parameters. That we will see few of parameters that are required mostly. Our motion limit is I have already cleared to all. I can assign any limit or at any axis and write it to the controller, and we don't need to do anything with this user defined origin, because it is the automatic generated that we have set the origin here. It is just showing the value here, that what is the origin value we are getting after setting the origin, and xyz limit is by default minus 10,000 to plus 10,000. So this is the limit for moving in linear motion. In this linear motion, we can also edit this xyz value. So we just need to define the motion limit for all axes. We don't need any xyz limit. So we can change according to our application, that envelope we need or some other safety purpose, we can change the value. So this is clear motion limit. And jog part is also clear to all, that L inching and H inching we can change as per our requirement, and the jogging speed also we can change in joint mode. And for XYZ also we can change this speed of the motor or the axis, and L inching and H inching we can also change. So this is the jog part. Or any hand or weight and size or tool we are not using, but we use, then we need to edit that parameter here. Like just for an example, I will be using one uh, like vacuum gripper here and mount on the z axis. So I'll just write out z axis. My tool length is 100. I'll take 100 standard tool, and I write it to the controller. Then my position will be changed to plus 100 in z direction. So now the robot, before it was on the 000, like on wrist part. Now my tool is added in this robot. Now all the position xyz reference value will be 0 at this point. From this point it will take the values. And for TCP also, like tool center point has also changed. Now if I rotate the robot, it will rotate from this point, not from this point. See? Likewise, I can change my TCP, and it is necessary to change the TCP according to the tool. And just for the information of controller, we need to enter the weight and size of the tool we are using. So data 0, if we are using a tool 0, we have taken the tool 0 here. So we will be using the data in here. For just for the information, we will add the information. Like we are using any 3 kg, then I will write 3. And size, I have already like in x, y, z, what will be the value? We will just put it here for the information for the work and write it to the controller. So this is the information I have given, and this is the tool I have given. And what if I need one more tool on same robot? I need one more tool mounted on the same robot. So I will use the tool 1 here. Tool 1. 0 is my okay, I have already taken, but I need one more tool. So I have selected 1. And for tool 1, any value I will be taking, I'll enter at this MEXTL1. So if I need one more tool, I will select 2 and enter the information in TL2. Likewise, we can add 16 number of tools on a single robot, but for 16 type we need another, like we need to dismantle the disassemble the current tool and assemble the required tool again and again. Likewise we can use 16 type of tools. The tool part is clear to all. Anyone having any doubt?
Participants, do you have any queries? Can unmute and speak, or you can post in chat box. I have shared the feedback link in chat box. Now I am going to share it again. Please fill that feedback form.
So I think it's good with everyone. Now we will see few more required options by tomorrow. So we will end the today's session here.
Sir, here one person, Shahal Hamis sir. What are the advantages of this robotic arm? Advantages.
Okay. Main advantage is the we can get the maximum output from our robot, like in production it will do very fast operation that a human can't perform, and we can use each and every second of our robot for reducing our or in our cycle time. So this is the main advantage. Second thing is where the human can't work, it will work, because we have oil-based robot also, and clean-based robot also, where difficult for an human to do the work. So these are the advantages, and main and most important is the robot will go to same point where you have created the point. It will remember that point and will go to exact same position again and again and will perform the operation. So there will not be an inaccuracy during the any operation or application we are performing. So
If you have any queries, please participants, you can post in chat box or you can unmute and speak. This is the time to wind up the section. Tomorrow at the sharp at 10:30, the section will be started. Thank you, Paras Mehtra sir, for your valuable knowledge contribution.
thank you so
Sharing
much.
knowledge, sir. Thank you, sir. Thank you.
Okay. Thank you everyone for joining. Hope you have cleared some topics and doubts related to robots. Thank you so much.
Thank you, sir. Participants, if you don't have any queries, you can leave the section. Thank you all.